So this is our dataset with plastic bottles. So it contains a lot of images, I think 25 images, and we have a lot of variation in these images. So you can see that the rotation of the bottles is there, and there are a lot of bottles within a single image as well. So we have a big variation. So include variation in your dataset, have any dataset, and we will be annotating this dataset with the help of vott tool. So this is the vott tool. You need to click on the new project. Within this, you can give any name to the project. In the display name, I am giving plastic. Then we need to like choose a source and destination for our annotations. Our source will be the dataset folder, and our destination will be the new folder that I just created, which is output. Okay, so we will add this in the source and destination in the project settings. So you need to click on the source connection, add connection. Okay, give any name. I'm giving images. Okay, choose a local file system, select the folder, and within this, you need to select the dataset folder. Currently, this is not the right directory for this, so let me just get back to the original directory. Within this, I choose a dataset. I just copied that dataset URL from the task bar. Okay, let me just copy it. Okay. Once I copy it, let me just paste it there. Now I have that dataset folder selected. Just choose the folder and save the connection. Now you just need to select the target connection. Same thing. I give a name, images. Okay. The provider will be the local file system. After that, select the folder. Within this folder, we have the output folder. Okay. Just select that and save connection. So now we need to like select the connection as well. So click on the source connection and the target connection. Okay. So let me show you. The source will be the input images, and output connection will be the folder where our annotations will be saved. So I have chosen the source connection as the dataset and the output connection as the output folder. Okay. So there our CSV file and all the annotations in the JSON format will be saved. So let's save the project. And once you save the project, we can start annotating the data. So let's get into the annotation. Before that, we need to add the label. Currently, we have the label as plastic bottle. So let me have the label plastic. Okay. You can have any label of your choice. Okay. So I'm giving it a plastic. Hit enter. Once you hit enter, you can select uh, the polygon, that shape, and start recording. So this is the annotations. You can start drawing it anywhere. Let me show you like this. You need to double click once you finished, and after that, if you see this cross, you can select the plastic region, the label. Once you select that, you will see that green color. Okay? And you can start annotating other letters as well, like this. You need to double click the image and select the label so that the annotation will be allocated to that particular object. So when you are going to save this annotations in the CSV file, we will come to that later on, but that will be saved in the rectangular format, which is xmin, ymin, xmax, and ymax. So there will be only four coordinates. You can see that there is a little bit greenish area uh, alongside that annotations, that polygon annotations. So that entire bounding box is being used to detect the object. Okay, so the bounding box contains the xmin, ymin, xmax, and ymax. These are the coordinates of the rectangle or that bounding box, you can see that uh, little bit fader area. Okay, so let me do it as quickly we can enjoy that. Okay, so it takes a little bit time. We have around 25 images, so make sure you annotate all the images, and images should have the variation. So this is from the water. Let me draw it. So annotations takes time. So this is just the beginning of object detection or object recognition. You can also train with like any of the object you want to detect or recognize from your desk or anything. You just need a few images with variations of that object, and that will work. YOLO works with very less number of images. Because there are other algorithms which works with like which requires many images, but YOLO is not one of them. YOLO with 100 images you can have a decent output. With around 300 images, that would be great output. So currently we have trained with 25 images, so this is also good. We will get into the training part, but just a second. Enjoy the music. export settings, there is the left hand menu bar, and there is one arrow icon for that export settings. So I'm going to click there. So that let me just adjust the things. Okay. So we have all the annotations done. Click on that arrow button. Okay. Now select the CSV file, comma separated CSV file. Okay. After that, only tagged assets. Okay. And save export settings. Now export settings are saved. We need to export the things. Okay. So for that, there is a icon, the arrow icon there at the top. You need to click on that, and that's done. Okay. So the export will be saved in the output folder. Okay, you will see bunch of JSON files and a VOTT CSV export. That VOTT CSV export is very important. We are going to use that. Okay, so this contains images and the CSV file with annotations. Okay, so let's move towards the important part, which is the GitHub file. So you need to copy that URL. Okay, of this GitHub, because this is the training pipeline and inference pipeline for the YOLO. So we will go into the CMD part right now. Click open the CMD and type in this command git clone that repository name, okay, dot git. So it will download everything. It will take little bit time. So let's wait till it gets downloaded. So now open the folder. Okay. So this is the file train your own YOLO. Okay. Go into the data folder, go into the source images, and we have training images. Okay. You need to select all and delete. Okay. So these are not our training images. We are going to train with our custom data set. So we need to delete all these images. Also need to delete the VOTT CSV folder as well. We have our own VOTT CSV export folder. So we will delete everything. Let's select all. We can select all and shift delete so that it won't take much space on your hard disk. So once you get that done, you need to go into the output folder, select all. Okay, so this is our CSV export. So you need to select all the things. You can also select only that folder, but uh, we are going to select all the things. Okay, because we might require them later on in the next project. So I've selected all the things, copied, and I'm going to paste it in the training images. Okay, let me first delete this folder. Okay, okay. So let me paste it. Paste. Okay. So we have our own annotations here. 27 items. Uh, there are 25 images and annotation file. Okay. Now we are going to upload entire thing in the drive. So we prepare for that. I'm just copying the folder, the path here. Now need to go inside the drive. Okay, so this is my drive. Okay, and I'm going to upload the entire folder here. So click on the new, click on folder upload, and yeah, train your own YOLO. You can upload that. Okay, so it will take few minutes. I have good internet connection, so it will take only 1 minute. Okay, now it's uploaded. You can get into the train your own YOLO. Okay, and there is one IPynb file, train your own YOLO.ipynb. You need to click on that. It will open into a Google Collaboratory. Okay, so this is the very important tool for all the machine learning engineers and data scientists. Once you are in the Google Collaboratory, you need to first mount your drive. Okay, this is how you can read all these things, but I'm directly going to mount the things. Okay, so first let me see if there are any other sessions. You won't see anything here, so you don't have to worry about that. What just I did. Okay. I just removed all the running sessions of the collaboratory. You won't see that. You just need to click on the runtime and select your GPU type, okay, or runtime type to the GPU. Now you need to click on this cell, run this cell. Here, when you run that cell, you will see that there is a link, and you need to click on that link. Then you need to select the account, and you need to copy that code into that link, okay, and hit enter so that you will mount that cell, okay, or drive. Once you mount that drive, you will see everything here in the training section, as well as the testing section, inference, and lot of things which are available in the drive. Okay, so I have to go into the convert your YOLO inside that image annotations. Once you are in that, you need to change few things. First, your vott export. Okay, the file name of the annotations. We have that file name as I think plastic.csv. Let's see. Source training images, vott export. If you go down, you will see plastic export.exe CSV. Okay, so we need to name that 24th, I think 26th line as plastic export.csv. I just copied the entire part. Let me remove things. So plastic export.csv is done. Okay, that's the change you need to do. Okay. So this is very important thing. You can read all the code. It's self-explanatory. If you get anything, you can let me know. It contains a lot of things. Uh, the annotation passing will be done here. It will automatically generate the data classes file, as well as the annotation file, the requirements which are required by the YOLO pipeline. So that's done here. Okay. Okay. So there are few more things here. We need to install the requirements as well, but we will see in the training folder before that. So download and convert YOLO is there. So this download and convert YOLO weights.py will download the pre-trained weights by the YOLO, which will be used for the transfer learning. So these are some URLs for that, but we will download them programmatically later on. So we can manually go to this URL and download the weights as well, but we will do that programmatically. So these are some URLs for the YOLO Tiny and our YOLO. So there is TrainYoUNYOLO.py. This is the important thing. The TrainYoUNYOLO.py, we need to change few things here, including the batch size and other things. There are some arguments passed here. You don't need to worry about them right now. We will get into the pipeline deeper in our future projects, but currently we don't need to get into the deep thing. Okay. VOTT exports, the Keras YOLO will be used. The Keras will be used in the backend, so it's a Keras based model. Okay. The YOLO.h file will be downloaded with the download and convert words file. Okay, and let's get into the arguments here. So there are few arguments here: file names, the class name, everything will be generated. Okay, and here the train and split ratio will be also there. We are going to use that as 0 as to 1. You can read all the things in the help is equal to. So you have all the things. And now in the bottom thing you can see that there is epochs here. Okay, we need to change this to 100. The more epochs, the less will be the loss. Okay, so it can stop early if it feels that the loss is not going to decrease, it will stop. But we will set this to 100. Okay, so you need to change this default value to 100. Okay, 100. Once you do that, there are few more changes required. So you need to get down. I don't think there are any changes above this argument, which is above. So currently we are not training with the tiny model. We are going to train the entire YOLO. So YOLO tiny will be the false. Okay, it is by default false. We haven't changed anything yet. So this is our project directory, train your YOLO. So that's important. Train your own YOLO. This will be the trained weights as stage one. There will be the loss will be like that. Steps per epoch. So we need to change these things. We are going to have around 10 steps per epoch. So let's remove the max thing. So I've commented down that entire line. So steps per epoch will be 10. Okay, and steps per validation steps will be also 10. So we are going to manually put 10 for that. Okay, so remember the line names and don't forget to add that comma after after the 10. Okay, so here is the train final.h file. We will save our model. We will not save our entire model, we will save only the weights. Okay, so that's it. I think there is no need to change anything. If you have like a different directory than train your YOLO, then there are some things that you need to change. But do have the root directory name as train your own YOLO. Otherwise, you will screw up. You need to change directory name in this code itself if you have other directory name. Okay, so I think this is it. So like this, the project directory is train your own YOLO. You need to change a lot of things. Okay, so let's close this. Let's control S and it will automatically save, but control S is better, always better. I don't think there are any further changes required. We have input shape that will be 416. If you are going to convert like this model to a different model, RTF Lite or any other model, you need to know that shape. For this session, we have 416 by 416. So let's download our YOLO models. Before that, we need to like install the requirements as well. copy few things here. Yep, install. Okay, so we need to copy that. We need to add the code here, paste that down. Before that, we need to get in the correct directory. So the directory will be train your own YOLO. For that, I'm just going to copy paste that cd command. So you need to click on that three dots, copy the path of your train your own YOLO. You need to paste it there and run. So this will take a little bit time to install all the dependencies. Yes, now TensorFlow is getting installed. After this is done, you need to restart the runtime. There will be an option there. So let's see. Now it's done. Let's see. Okay, so you need to restart the runtime. You can see that restart button. Yes, restart the runtime. Once it's restarted, we can move ahead with our very important thing. Download the weights. Okay, you don't need to worry about anything else. Just do as I said. Now we need to get into the training section. So copy the path of a training session, paste it here, and run the cell. So it will download all the paths. It is completed. We can just move ahead with train YOLO.py, but there could be an error if you are not completed the annotation section. So we need to run the annotation session. I hope this will give us an error. Yeah, so there is a error because we haven't just a second. Okay, so the error is correct. We haven't run the convert your annotations. Okay, so we need to choose that path from the image annotations. Okay, we need to add a code block here. I have added a code block. We need to change the directory cd %cd. Okay, I can indirectly do it as Python. Okay, so let me see. in the training session, now you must have the classes, the text and data classes and lot more things. So you can see that data train the text is there. So it's successfully completed. Our passing the annotations is successfully completed, and let's move ahead with the training session now. So you have to be in the correct path. You can do CD to the training session and then run this file. Okay. So this will start the epochs, training epochs. We have 100 epochs, batch size 32. Okay. We can do some variations, but that's okay. We have batch size 32, you can change that, and there are a lot of things which you can change, but there is no need. So it will go for 100 epochs, it will take some time. I will pause the video and come back again. Okay. So the time won't be that big, but it will take some time to do some. So now you can see that entire epochs are done. We went to 140 epochs with early stopping as the loss being low than 19.5. So you can see that we have some models. Train weights final.h5 is the required model. Okay. So we will get into the tensorboard now. You need to change the directory to the YOLO format, YOLO file, train your own YOLO, which is the root directory. Once you are in that, we can go ahead with the tensorboard. TensorBoard is kind of used to like visualize your statistics about the model. Okay, it will show you the losses functions and a lot of things. If you have a multiple models, then you can use TensorFlow to like choose one of them which is performing better and choose that for testing. So currently we have only one model, so let's get into it. You will understand that. So in directory currently we have data model weights as a log directory where our model is saved. So it will take some time to load the TensorBoard. Once it's once it's loaded, you can see a lot of things there. Uh, the graphs and a lot of things, the time series and the graphs. You can see a lot of things. The graphs, there will be like hierarchy of all the layers, and the time series also have the epoch losses. Let let's get into the inference. So you need to get into the that directory, inference directory. You need to run this command python detector. That you need to choose which images you are going to test on. Okay, we are going into the test images directory. We need to clean that directory before adding our new images. So let's get into that. So I am currently in the test images. You can see a lot of images here. You need to select all and delete. As well as in the test image detection, there will be some images of pre-trained model, detections of the pre-trained model. You need to delete them as well. Okay, now we need to get our inference running. For this, first we need to get into the test images session in the data source images and test and test images detection, and you need to delete all these things in the test images. As well as we need to delete things in the test image detection, this folder. You need to delete everything within this. Once you delete all these things, we can move ahead with the inference code, which is our testing code. So now we need to get into the bottle images. Once we have all these images, we need to like download few images. We can download few images from Google and save it in any folder. We need to upload those images into the drive. So I have downloaded three images here. Let's download all the three images. You can choose any plastic bottle because we have trained with the plastic bottle, so we need to detect with the plastic bottle. You can try with the metal bottles as well, but it depends on the shape of the bottle. As well as okay, so let's upload all these files. Where are these files? Okay, let me just copy the path, new file, and upload. once everything is uploaded, we can run the inference code. Okay, let me refresh the runtime a little bit. Okay, so images are there in the test images session. So test image detection will be the empty folder. There our detected images will be saved. So once you run this inference, it will take few seconds. For the execution or the detection, it will take around 0.08 to 0.07 seconds. But to load everything, it takes a little bit time. So you can see that the detection is going on. The first image took around a lot of time, but afterwards it took very small time to detect the images around 0.67. Okay. Once you have done this, you can go inside the test image detection to check on the detections. You can see that inside this folder there are the detected images with the confidence of the detection and the bounding box. You can open it by double clicking the image. Let it load, let it load. So you can see there is a bounding box. So this is the image, and for this image, this is the detection. You can see for some images it gives 100% confidence. For some images it gives 90 to 100% confidence. Depends upon uh, the variation that you have annotated and the number of images you have annotated with the data set. Okay. So thank you. Let me know if there are any difficulties finding the YOLO detections, okay, or any other difficulties. Let me know.